Hello everyone, welcome to OdinSchool. Today in this class, we are going to learn about a very important concept in advanced statistics, which is simply nothing but learning about bias, variance, stats, inferential statistics, and how to plot things. Now, we are going to learn about all these different topics with detailed examples in this class. Before getting into the today's content, let's first understand why should someone learn statistics, and from there we will be able to proceed with the next continuous topics. Statistics is a very important subject irrespective of your professional career. Even if you are going to a non-IT department, it is still going to be very relevant and useful because statistics is a subject that we use generally in our both public as well as personal life, in professional life as well. Now, any decisions that we take in real time is based out of numbers. Generally, if I have to go to a particular place, if the traffic is too much for me to travel in a particular route, I'll have to take another route. Now, this all these calculations based on traffic happens with regards to time and by numbers. Like route A will give me 30 minutes lesser travel time than route B. So this 30 minutes is a quantitative output which is generated using a statistical measure only. So every day in both personal as well as professional life, we all use statistics directly and indirectly. So it is really essential to learn and understand what are the key factors that contribute to the performance of statistics and how statistics can be put in use in both the real life scenarios as well as our personal life scenarios. With that said, let me quickly introduce about OdinSchool. OdinSchool is a technology upskilling platform. They help us continuously acquire new skills. Their motto is to stay skilled and stay ahead. About me, I am Gautam Kumar Jayachandran. I have 6+ years of experience as a senior data scientist. I work in several technologies starting from Excel, SQL, Python, Tableau, machine learning, and Alteryx. I currently work with financial domain. Let me get you through the today's agenda. The first thing that we are going to learn is bias, and we are going to learn about variance. We are also going to learn about what is the trade-off between bias and variance, because generally when there is bias and when there is variance, they don't go hand in hand. If there is an impact in bias, variance also gets impacted. We will see what is the trade-off and how best we can stimulate both in order to achieve good bias and variance. Then we are going to learn about inferential statistics. What is inferential statistics with a couple of examples. Then we are going to learn about two important plots, basically charts. There are several charts that we can do, but these two are very important: the count frequency distribution plots and the histograms. We will also learn about scatter plot in today's class. Let's get into first content: bias. Bias is, to put in layman's term, it is simply nothing but favoring towards something. If say for an example, you are a person who likes India team. When India team and Australia team are playing against each other, we tend to support Indian team because we like Indian team. If you like Australian team, you're going to support Australian team. So this is like a choice that we make in our own interest. It is exactly the same way in a data set also. How a data set tends towards a particular subject or a particular member in the population. That is all biases. It can be favoring a portion of the population. It can be for favoring the entire population, or it can be favoring a particular parameter inside the population, and multiple other things. So bias is simply nothing but favorism or tendency towards a particular portion in the data set. Now, theoretically, bias is simply nothing but the tendency of a statistic to overestimate or underestimate a parameter. When you are already biased towards it, even though you know that India is going to lose a match against Australia by the run rate and the required other things, you will still believe that India is going to win because you are overly optimistic about your side winning. That is exactly the same thing with bias also in a data set. Bias, it will not see the flaws that this particular population has. Rather, what it will do is it will counter it will overcome the drawback as a as an advantage to it, and it will not worry too much about the oversight or the flaw that we have in the data set. So that becomes a problem. To put it in very simple words, now assume I am going to a food competition as a judge. I generally like eating spicy food. So what happens is, in the food competition, there are three, four participants who are preparing food, out of which most of them have prepared a normal bland food. There is not, the foods are not very spicy, but one contestant have prepared a spicy, really spicy food. In that case, my winning vote, being as a judge, I am already biased towards the spicy food. So what happens is, my vote will generally go to this candidate who has prepared a spicy food. This is bias. This bias actually causes a problem. This will not give you neutral result. Eventually, I should, as a judge, I should figure out what is the best food, and I should honor the candidates and award them. But rather, since I am already biased towards something, it becomes really tough as a judge, or as a human being also, to stand unbiased. So that is the understanding towards bias. Now if you see this particular chart, if you see the particular chart, towards, this is my mean. If you see here, what you see here is a mean value, simply our mean value. If it is around the mean, if most of your data points are around the mean, it means less bias. It should be very as close as possible towards the mean. But if it is staying far away from my mean value and favoring a particular portion in the left side of the diagram, left side of the data set, or in the right side, in both the cases, they are actually high highly biased towards some end. They are actually not distributed towards the center. That is something which causes bias. We will talk about variance in the next topic, and let me give an example for that. But the idea of bias is favoring towards one particular end in the data set. Let me show a couple of examples for that. Now I'm going to take a data and then play with it. Let's take this data. Okay, perfect. So with this data set, now let's see. Let me take the count of all the products that we have here, and I'll also take the average count. Now average, I'll simply write average products, average count of products. Yeah, so calculating average count of products, what I'm going to do is, I'm going to take average units sold. Let's see here, on an average 34.71 products have been sold for each and every sale that happened. Now let's do the same thing for each and every product we have separately. Just applying the units range here. This way we will be able to see the values without manipulating anything. Let me just keep the numbers in two decimals. Look at this. We have values starting from 31 till 39, and in middle we have 34. If you plot these numbers, 31, 32, 33, 34, 35, 36, 37, 38, 39, the data is actually distributed in this range. This is the range in which the data is distributed. Now how many data points are there? 1, 2, we have 5 data points in our product section, but considering this scale, we have 9 data points as a scale. But look at this, we have 34.12 or 34.68 or 34.48. Maybe we can keep 35 as our middle or our center. From 35 there is a data point to 31, there is a data point towards 31. Here there is no bias because it is equally distributed from the center, and we have only one data point here, only one data point here. All the other data points are around the center only. Here we have very less bias or no bias also. Let me plot the same in a scatter plot and explain it. Let us plot some chart. I have to just use this to plot charts. I'm just using this. I just wanted to see how the data is distributed. We can plot a lot of charts, but scatter plot, yeah. We'll talk about scatter plot and what is the advantage of using a scatter plot in the last piece of this class. But if you see here, let's plot the mean value first in the chart. What is the mean value? 34.71. Let's keep it as 35. I'm going to choose this color. I'm going to plot it somewhere here. If I plot these data points here in around 35, what happens is most of my data points, almost all the data points that we are seeing here are very close to my mean value. Look at this. This is my pink line is a mean line, and few majority of the data points, almost like 60-70% of the data points are falling within the mean, and the deviated data points are also not far away from the mean. They are very close to the mean value. So if you see here, the data point is distributed like this. Yeah. So in this case, we have very less bias or no bias. But let's plot the same thing in our huge data set and understand how bias will come into picture. Now what I'll do is, I'll not do anything, but I'll simply plot scatter plot on units section. What's the mean value of units? 34.71. Now let's plot the same thing. 34.71 should be somewhere here. Yeah, in this case, I am able to understand some pattern in this. The pattern that I'm trying to understand, or the pattern that I'm able to see here is, look at this. There are many data points, are equal number of data points in the left side of the mean as well as in the right side of the mean. I'm not seeing huge difference in terms of data points present from the left side as well as the right side of the distribution. In both the cases, we have almost equal number of data points distributed. In this case, we can quantify this as less biased because I am saying that there are a little more data points present below the mean than compared to the higher than the above the mean. So in that case, it is biased. Definitely, this is biased, but not very highly biased. This is very lessly biased. Any data set in real time will always be biased. There will be no unbiased data set in real time. We can create unbiased data set in for academic purposes, but in real time there will be no data set such as unbiased data set. All the data set will be biased towards some or the other end of the distribution. When I say some or the other end of the distribution, the ends of distribution are always calculated from the mean. From the mean, whatever that goes up becomes my right side, whatever that comes below becomes my left side of the data point, left side of the distribution. That is how we can understand the bias. Now you can ask me, I understand bias, but why should I know it? The problem is, calculating bias helps us understand how well your data points or your observations in the final output will differ from each other. Now, if I wanted to calculate what I can calculate, the average sales in each and every product, where the average number of units sold is equal. Now in this case, sunshine, let me color them so we will be able to distinguish the output. Sunshine I'll color, anything that is 34 I'll color. In this case, if I calculate the sum of sales achieved by all these products, what happens is these will give me values which are not biased to each other. But if I take the sum of Calata, it will be completely different from the other products. Again, the same happens with Quad. I'm very sure the sales of Quad will be very less. The sales of Calata will be very high. Basically, this product is the maximum performing product and this product is the minimum performing product. Just to prove my statement, what I'll do is I'll simply calculate sum if and the criteria is this, the range is this. Let me plot the same here. Let me add variables to this. The currency, yes. If you see this, in this case, look at this, the sales happened in, did I change something here? J3, J4. Yeah, this is fine. This is totally fine. The calculations are correct only. Now let's see. In this case, what we have is we have values calculated for each and every product using sum if as a condition. Now in this case, the sunshine's value is 16,000, the sunset's value is 12,000, and balance value is 11,000. Looks very close to each other. But if you see here, Calata has sold 19,872 products, whereas in Quad we have a very huge value. This should be because the cost of goods sold in this particular product will be very high. That will be the reason why we have Quad as maximum value. Let me show you what will be the cost of goods sold, average cost of goods sold for every product, so we will be able to understand why there is a huge value in Quad. Now this is actually biased because Quad has more value than what is this, uh, any other products that we have, so that way it will be able to generate more sales as numbers, even though the average count of products, it has sold the least amount of products in the entire uh, in the entire products list. So let me calculate the sum of, this is my criteria and my sum range is cost of goods sold in this case. Look at this, as we understand, the cost of goods sold for some Quad is way too much compared to every other product. It is in fact double than any other product, almost close to double, 12,000, very close to 12,000. That is the reason why we have huge value in Quad. But however, the point is it has sold the minimum number of products. Clearly there is a bias in the form of Quad. So whenever, if I'm not aware of this bias, this particular influence or particular favoring towards a product, when I calculate an average generally without knowing this, I will be understanding the business incorrectly. So knowing the presence of bias helps us either control the bias or helps us understand the business in a different perspective, which will be the right understanding. So it becomes really essential that we perform or understand how the data is distributed and where is the bias and all the other things, without which it will be really tough for us to calculate the right or accurate, what I would say, accurate output that we would be wanting. So it is really essential that we understand this. Let's go on to the next topic. The next topic that we have is variance. Talking about variance, variance is simply nothing but a concept, a statistical concept, which helps us how wide or how spread your data points are from the mean value. It is as similar as your standard deviation only, but standard deviation is the square root of variance. So we will have a squared value in terms of variance if you are seeing variance directly. So let me explain this with an example. um yeah. So if you see here, variance is simply nothing but the average of the squared difference from the mean. Rather than taking the square average difference, it will take the squared difference, because standard deviation is the average difference. Variance can be calculated by squaring the standard deviation. I think this is exactly what we spoke. Now see here, this is the mean value in a distribution. Let me use this. Mean value is what we are seeing here. So we take this, make it a little thick. This is the mean value. What we are saying here in the pink is mean value. The data points are distributed like this. These are the data points. Now, the distance between the data points and the mean value is what variance is. It tells you what is the difference in squared numbers. If the distance is 5, it will give you 25. That is what variance does. The 5 that I said is actually the standard deviation. So we will be able to understand how wide the data is spread. Now you can understand the relationship between bias and variance. What is bias? Bias is if the data is distributed very closely to your mean value, it will be less bias. Here, this is my mean value. If it is distributed very close to my mean value, it becomes low bias. Other which ways, if it is spread far away from my mean value, if it is distributed far away from my mean value. But look at this. This is not spread in several instances. At one place, data is grouped or data is accumulated, noise is there, too many data points are there. But in variance, this will not be the case. In variance, it will be very highly you know distributing. It will be spread widely from the mean value. From the mean value, it will be spread so far in several places. Various bias is simply nothing but accumulation or noise in the data set. Talking about variance here, the data point is not so far away spread, or not what I would say, not spread in several places. It is spread, the data points are spread in only one place. That too is around the mean value. So in that case, it is low bias and low variance. In real time, achieving low bias and low variance is the ideal target that we will keep for ourselves to achieve a data set, or to prepare a data set. Once we prepare a data set with low bias and low variance, that becomes the ideal data set for performing analysis on top of it. This is what we need to try achieving. But it is not as easy as I said. It is really, really tough to handle bias and variance together, because they are very close to each other in properties. Now, let me explain the trade-off using a chart. If you see the bias variance trade-off, the bias variance trade-off here that we have is simply nothing but, if I have low bias and low variance, this is the optimal solution that one can have from processing the data while preparing the data. This is the optimal solution that we want. Let me just delete this. Okay, so in this case here, this red, what you see in red is basically the mean value. If you have the data points distributed around the mean value and not very widely spread from it, you look at this, this is spread equally proportionately from the mean. This is the ideal situation. We have very less variance and we have very less bias. Various, talking about high bias, look at this. It is the noise that we have in the data set, but it should be residing far away from the mean value. Now to now simplify this even better, I'll just delete this. This is my mean value. From my mean value, there is the group of data points that are present. This is actually high bias in nature. What is bias? Bias is favoring towards only n. Even though you have so much of space in the data set to distribute these data points, most of the data points, or almost all the data points, are present in one portion of your data set. The other portion is completely empty in nature. So in that case, what happens is the output will be favoring towards this particular particular piece of data only. So what happens is, rather than knowing all the questions and the answers, you will be knowing only one question, one answer, and all the questions will be answered with that only one answer. So that becomes a confusion, or that will not be the right approach as well. So what we will do is, we will see first what is high variance. High variance is how widely the data is spread from the mean value. From the mean, look at this, there are so many data points present, but all the data points are shattered at several places wide from each other, wide from your mean value, far away from your mean value. This is your high variance. What is high bias and high variance? Look at this. In this case, the data points are present across the data set. Various in high bias and high variance, your data points are very widely spread in only one direction, which is basically bias in nature. Hence, it causes high bias and high variance. But what we need to do is, we need to achieve concept called low bias and low variance. Now you can ask me, how do I control bias and variance together? This is exactly where trade-off comes into picture. And bias variance trade-off is simply nothing but a concept which explains what happens when I introduce or reduce my bias. Now let me draw this and explain this with an example. Yeah. Okay, now assume there are two data sets that we have. Let me create some data sets. This is variance that I'm plotting here. On the left side, what you see is bias. That is the mean value. Here also, this is my mean value. Let me reduce the size now. Now, the question is, how do I handle these two situations? The one we see in the left side is basically high bias. Let me write it as well, so we will be able to understand what we are doing. This is basically high bias. And we have high variance also. Perfect. So in this case, how will I handle these two situations? When I have bias and when I have variance in my data set, how can I handle them? To handle this, there are two ways. There is one way to handle bias and there is one way to handle variance. Let me show you how to do it. Yeah. Now, in this case, since the data points are distributed at only one particular place, if I distribute them, okay, let me increase the size a little. If I distribute them equally, or if I try to distribute them far away from only one direction, what happens is your bias will get reduced, but now you would have created a data set with a lot of variance in it. Talking about variance, the problem is the data is far away spread from the mean value and widely distributed. Since they are widely distributed, we can try grouping them very closely to each other. Now your variance might be decreased, but unfortunately you will have created bias in the data set. So the problem of bias and variance is not as simple as we speak. If I handle bias, then variance will get increased. If I handle variance, then bias will get increased. So bias and variance is a trade-off. If I give one, another one has to be there. If I give the other one, the remaining one should be present in the data set. So either I can have bias or either I can have variance, but you cannot handle or remove both the concepts from the data set, which is really tough. We have to do a lot of data manipulation if we want to achieve no bias and no variance, but that data manipulation might kill the context of the data itself. So it is advisable not to do data manipulation to handle this. We can do data manipulation but not at a very higher level. We will do very simple data manipulation, we and then try controlling the bias and variance. But the problem is, controlling bias will increase variance, controlling variance will increase bias. So we need to control both. If I rather than grouping the rather than degrouping, disaggregating the data into the entire data set, I'll try grouping it at few places where I will retain few bias. Also, I will be handling variance. Talking about high variance, I'll try to distribute it as several groups. So that way, what happens is it will have both bias and variance, but it will have very less bias and variance. So that should be ultimate aim in a data set to achieve in order to perform a analysis on top of it. This bias variance concept comes in picture in the data pre-processing itself. When we are cleaning and preparing the data, we should be able to understand how and when bias and variance will come into influence the output that we are going to generate out of it. So it is really essential that we handle them before performing any analysis. Even in our case, when we generated or performed the sales average units sold, we did have a lot of discrepancies in terms of number because of the presence of bias in it. So if we are able to handle the bias, then we will be able to uh, decrease the values a little. Now, to just give an example, now we have these values. Look at this, the value. The problem here is the cost of goods sold for quad is way too much. It is like twice as much as other products. But in this case, if I have to control this bias, what I'll do is I'll take only 50 percentage of each cost of goods sold. That way, the variance that I had here I had it as 11,861, whereas here the value got reduced, even though the percentages are same. Even though even now the quad has twice as much as cost of goods sold, but still the value got decreased. This is one way of handling bias and variance in this case. Now I have handled bias, but since I have handled this, if I try plotting this again, it will cause variance in it. So there will be, if I give one, I have to take one. That is the concept of bias and variance trade-off. Let's go to the next topic. The next topic is inferential statistics. Okay. Inferential statistics, I think from the day one we are learning about several types of uh, population and sample concepts. Inferential statistics is something which is very similar to that. The idea of inferential statistics is very simple. Rather than focusing on the entire data set for performing um, analysis, in the interest of time and resources, we will be performing those analysis on a subsetted data rather than calculating the average score by the Indian team. We will from all the matches, we would rather take it from the last 10 years of data and then calculate the average score and try to infer back to the population. That's the idea of inferential statistics. Typically, almost all the analysis that we do in real time is inferential in nature, because having a population data set is really tough. And even though if we have it, storing them, processing them takes a lot of time, money, people, and other resources as well. So with that said, let's see how inferential statistics can be used to generate some some potential information from the data set. The image is self-explanatory. As you see here, we have the entire data set. Rather than taking the entire data set, we will take a particular group of people from the population and perform descriptive statistics on it. When I say descriptive statistics, there are several statistical measures like mean, median, mode, and all those things, and that becomes my inferential statistics. There are two types of statistics. One is descriptive, another one is inferential. Let me explain both. I'll also tell you why do you need to know what type of analysis or what type of statistics you are using, because the functions that we are using also will differ based on the sample or population. To just give an example, if you see standard deviation or standard variance, there are two functions. One is for population, another one is for sample. So if you are working on descriptive statistics, you will be using this function, standard deviation population. Other which ways, if you are working on a function or working on a data set which is a sampled data, then you will be using standard deviation sample. So it is very vital that we know what type of data or what type of analysis are we performing. Are we performing population analysis on the entire population, or are we performing analysis on the sample only? Now to do this, see what I'm going to do. First, this is the entire population that we have. In this case, I'm going to perform some basic operation to understand this business. So I wanted to know what is the sales representative's name, and what is the average units they have sold, and what is the average sales that they have generated, and what is the average. Okay, maybe here we can have sum of sales that they have sold, total units I would say, and then we have total cost of goods sold. Then finally we will calculate profit. Now this will summarize me the entire data that we have with few numbers only. We don't have to calculate so many numbers. But for sales representative, first let me take the minimum counts that we have. There are 8 sales representatives, which is a huge number. So I'll just create a table to explain the sales done by. Sales are this information at each sales representative level. Okay, now in order to calculate things, what I'll do is I will calculate each and every level. Sum if units. The criteria is this, and sorry, I think I made the change. Sum if the range is sales representative. We are talking about sales representative here. So this is my criteria, and this is the units sold by them. So this will give me the total units generated by each and every sales representative. Franks have sold only 58 units in total. There's something wrong. Okay, there's a space in the francs, so I'll remove this francs. And looks like chin also is present twice. I'm not sure where it is present. What? Let's fix this issue. This is the data issue that we have. So we need to fix this issue. Other which ways we will be performing calculations at different level. Let me pick both the chins that we have and remove the issue in it. Frank is resolved. Talking about chin, there's only one chin, but in this case I am having two chins. Looks like we have some space issue. Yes, now it is resolved. It should be only one. Yes, exactly. Perfect. So we have the total units sold by each and every sales representative. Now let's calculate the sum of sales. Same approach, just the criteria and the sum range. And cost total profit, everything should be in dollars. So I'm going to keep them in dollars. Let's put this as well. Calculate the total cost of goods sold. The range is again sales representatives, and then the criteria is sales representative, and that here we are going to choose COGS. Talking about profit, profit is simply nothing but total sales minus total cost of goods sold. Okay, now look at this. Now I can understand who has performed better. Now if I wanted to sort the data and understand who has generated me more profit, starting from the least value, looks like Galt is the sales representative who has not performed up to the mark. Now if I calculate the average profit, let's calculate the average profit. Okay, I can simply, yep, I think this should work. The average profit is $7,189. Now in this case, if I do not know who has performed well, it is a very small table. In this case, if I perform a conditional formatting, I will be able to differentiate between the sales representatives who have performed above my average and performed below my average. The problem is I am even okay with Seahawks because Seahawks is hardly less than 108, 120, 140, $50 only less than the average sales. But talking about Galt, even Smith is fine because he's just less than $1,000 from the average value. But Galt has performed really bad in terms of sales because he has sold only 240 units, through which he has generated only $5,000, and the cost of goods was $2,000, and the profit he generated was only $3,000. So this is actually a concern for me as a business owner. This is exactly how you will understand business at the population. Now what I'll do is I'll quickly calculate the same thing at a population and show you how different or how close these values are going to be as a part of inferential statistics. So what we are seeing here, it is basically descriptive statistics. When I say descriptive, it is on the entire data set. Yeah. Now what I'll simply do is I'll simply create a random column just like usual to generate randomness in the data. Yep, this is just a number. Yeah, that's all we need to have. Let me subset a data and calculate the same thing. Here we have from 101 to 105. So I'll give the same thing as my range. Just creating something random. I'm removing duplicates here. Perfect. We have 47 data points in this case. So what I'll do is I'll simply choose this table and then ask the machine to get things from this particular table, and then I want the machine to give me the records in a different place. No longer I want this or this. Okay, now if you let me just get this data as close as possible and calculate the same thing on the population data set. If you see the population data set, we have only all 105 are present. It is weird. Okay, let me just randomly remove few elements. That way we will be able to keep or consider them as data points that is generally taken from the population without any control to it. Now how many data points I should have? I have 78 data points. I think it is still too much of a population, so I'll just try to remove few data points out of it. Yeah, this should be a good sample. Now I have taken only 68 data points from the entire population. Rather than taking the entire population, I've taken somewhere close to 70% of the population. Now let's see what happens. I should be having the same insight that Pham, Chin and Franks should be the people, sales representatives who are performing or who have earned greater than my average sales. Now let me remove everything, calculate them swiftly. Sum f, and my range is sales representatives, and then I'll simply say this is my criteria and the sum ranges column U. Then for sum of sales I can simply copy this. Instead of K13 it should be J13. That's all it is. For U I will simply say V. I'll simply change this into V. This is the sum of sales. Then talking about cost of goods. Cost of goods is present in the W column. I'm just changing that into W. Profit is simply calculated by sum of sales minus cost of goods sold. Now, yeah, I think I don't have to format this the other column. I'll simply format this. See here, as soon as I calculate the values from the sample, from the subsetted data, I have already written a conditional formatting asking the machine to show me the values that are above my average in the profit column. Clearly, Pham, Chin and Franks are performing better than the other three sales representatives and their sales value is greater than the average. Let's calculate the average and see it for ourselves. Look at this, the average is $4,754 and these sales representatives are actually performing more than $4,754. That way, as insights, as an understanding of the business, I can do the same operation on a data set or not on a complete data set, rather than taking the data set on a data from a complete data set. What we can do is we can take only a small portion of the data set randomly and calculate numbers. The numbers will give you the same insight as the population. This is the idea behind inferential population in statistics. Okay, let's go on to the next one. Histograms. Okay. Histograms and frequency count plot as we speak. These two are very important charts in real time. When I say charts, histogram is always used to explain data in a group. If I have huge number of data points and if they are not grouped or binned together, what if I group them, bin them and see how the data is present? Now the representation of histogram will always be in a range. You cannot have individual entities in histogram. It will be always within a range. But whereas in a frequency distribution, it represents each and every entity. That's the difference between histogram and frequency plot. But let me show you both with an example. Now for histogram, I don't have any data grouped here. So what I'll do is I would like to see how many sales happened within a particular bucket. So I'll simply create a pivot table first. I would like to create a pivot table here. I wanted sales to be present in both my rows and columns. So I will be able to create a bucket out of it. Now I'll right click the thing and work on groups. In groups, it starts from 126 and ends with 1728. So what I'll do is I'll ask the machine to start from 100 and end with 1800. I wanted to see how many sales happened in the interval of every $200. So 100 to 300, how many sales happened? 300 to 500, how many sales happened? Here I don't want the sum of sales, I wanted the count of sales. If I just give this, it tells me how many sales happened in the buckets, each and every buckets. Now I can simply go ahead and create a histogram out of it. Okay, it is asking me to copy the data outside the pivot. I'll just paste it here. Let me now change the, we don't want grand total, we want only these buckets. I'll go to insert page, create a histogram out of it. Histograms are basically this only, very closely packed bar charts. This is a Pareto chart that we are seeing, but I can remove the Pareto. We don't want to have this Pareto line. I'm not able to delete the Pareto line, but yeah, the idea is everything here is grouped together because the data is distributed like this. If I talk about an histogram, look at this. This is exactly what an histogram is. Every data is grouped together as a bin. Now, if I expand this, we will be able to understand this much better. Let me scroll this up. Okay, yes. Look at this. Now between 100 to 200, 100 to 300, 13 sales have happened. Looks like the products that are between 100 to $1,000 or $1,300 also performing good. Anything that is greater than $1,300 in price is not actually performing good. Among all the products that are performing well, products within the price range of 900 to $1,100 are performing really good, and products with the range of 300 to 500 is also performing really good. So we can understand the business using grouped values. Here it is not talking about any individual entity. Now if I wanted to know the individual entity, so what I'll simply do is I pick few data points here, and then I can paste it somewhere and then create a count frequency of it. Or maybe I can show you the same example. I'll just take the data set. I'll create a new sheet, paste them, and then create a count frequency. To create a count frequency also, I'm going to use existing worksheet option in pivot table only. I'm going to pick a product and the count of it. That's all I wanted to have. So now if I plot this value into a chart, into a bar chart, this becomes my count frequency distribution plot. Now I can understand how many times a particular product has been distributed in the data, which is a very important or a very basic requirement for any business understanding. Looks like the number of Quad has sold the more number of products, and Sunshine also has performed really well in terms of number of units sold. So this way we will be able to understand the business at an individual entity level. Here I can tell this is belonging to Sunshine, this is belonging to Quad. Whereas in histogram, it is all about the grouped values. What I know is products with the price range of 900 to $1,000 are performing good. Products with the price range of 300 to 500 are performing good. So here I am understanding things as a group, whereas in account frequency I understand everything as an individual observation. These are two important charts that helps us understand the data and how it is distributed. With that said, we have come to the end of this class. So let me quickly recap what we have learned in this class. We have learned about bias and variance, where bias is basically a noise in the data set present in only one particular location or one particular side from the mean value, and it should be a little far away from the mean value. Variance is present far away from the mean value, but it is widespread. Unlike bias, it is widespread. To handle bias and variance, we need to trade off between any one of them. Talking about inferential statistics is all about taking a subset from the population and performing logical operation to understand the insight belonging to the population. We don't want to use the entire data set, rather use subset of it and understand the business with the same context. Talking about histograms and frequency distribution plots, two important basic charts helps us understand how a chart can be used to interpretate business. If I wanted to interpret data at a group level, I can use histograms. If I wanted to interpret data at individual level, I'll go with count frequency distribution plots. That brings us to the end of this class. Thank you so much for joining this class. Please don't forget to like, share, and subscribe to this site, to the channel. Thank you so much one more time.